My research is on stochastic geomechanics. These are two catchy words to attract students to come into civil engineering because they always ask, what is stochastic and what is geomechanics? So stochastic is related to uncertainty. In civil engineering, we deal with many information that we need to manage, we need to process, so that we can optimize decision making when we're building infrastructure. And as a geotech engineer, probably from all the fields in civil engineering, we are the ones that engage with lots of uncertainty. If you compare a profession or a field as geotechnical engineer with a structural engineer or with a water resources person, we deal basically with geomaterials. And geomaterials were made by Mother Nature, so we do not define specifications to the material that we're going to be working with as a professional. So there are a lot of uncertainties on setting the basic mechanical properties of soils and how they behave with respect to time. And so that's stochastic. The other catchy word is geomechanics. So I already made some reference to the materials that we work with. But in general, as a geotechnical engineer, we need to assimilate information, all the geoinformation that is available to do the proper designs when we deal with infrastructure. So if you think on railroads, on roadways, housing, apartment buildings, schools, any sewage systems, power plants, any piece of infrastructure is embedded somehow or is interacting with the earth. And when I said earth, we're talking about soils, we're talking about rocks, and somebody needs to define what is that degree of interaction between the piece of new infrastructure that we're building or that we're retrofitting with respect to earth. And so that's the second part of what we do in our group. We do the uncertainty of what we want to define as which much detail of what we know about geomaterials, and the geomechanical part, which is everything about experimentation, modeling, testing, so that we can come up with the right answers for the design of infrastructure whenever it interacts with the earth. And we tell our students, so especially our new students, a piece of infrastructure that is not sitting or is not in contact with a piece of earth, it's impossible. So as civil engineers, we transform the earth for the purpose of, for the benefit of society. So all those pieces of infrastructure that I mentioned are to make our lives better. And we as geotechs are the ones that try to define that interaction between earth and infrastructure.
Well, so talk about that a little bit more. How does society benefit from having geotechnical engineers all around? I mean, I understand that it's the interaction of the infrastructure with the earth itself, but if I don't understand that sort of thing, I'm just a regular person on the street, how would you tell me that I'm benefiting from geotechnical engineering?
Well, I would like to respond to your question with one single word. In my group, our interaction with the societal benefits is called Georisk. We want to assess what is the risk of this interaction. So whenever there is an earthquake, we know that we can have some fatalities, and the earthquake is the earth that is moving that might generate some civil infrastructure failures. When we have mudslide, because we have fire last season and now the forest is gone, we have the rainy season and we have the mud that is coming, we can have hundreds of people being killed. And I tell this also to my students, there is not a single day in which you do not look for the news and you can tell people that are losing their lives because of these mudslides. Same with floods. So we want to accommodate this understanding of how the earth, the topography, the geologic processes, the mechanical characteristics of the soils, so that we can protect society, so that we can guarantee that all these pieces of infrastructure are going to be there. So if your house might be exposed to a potential rock slide, or if you're driving your car and suddenly you feel a bump that can take you out of the road, that is related to my job, because we want to guarantee that the interaction of the highway with the earth is properly defined so that you can have a smooth driving. So In my group, for example, we have done research on quantifying the risk for whenever you're exposed to snow avalanches, to rock slides, to tsunamis, to earthquake, to floods. So nowadays we want to assess what is the probability of these events happening. So I mentioned my research group is Stochastic Geomechanics. Stochastic is related to uncertainty. And the math of uncertainty is probability. So we want to assess what is the probability of having these failures or these geohazards happening. So we are the ones, at least people that we train in my group, are the ones that are responsible of coming up with that answer. This is the probability of this event happening on one side. On the other side, in my group, we're also specialized on assessing how many people will be exposed, how to relocate full communities so that we can avoid this kind of potential geo impacts or geo threats that can impact society. And in general, for any construction, lately we've been working on energy a lot. We're having a lot of interactions in my group with other engineering disciplines, particularly on energy. And if you think about building a city 3,000 meters below the sea level so that we can extract oil, you need to guarantee that there's not going to be a landslide that could wipe out $5 billion investment that will be just buried there after completed in terms of installation and facilities and functioning and operation. So in my group, we're very interested in quantifying what is that probability of having a small tremor that could trigger a submarine landslide that can eventually destroy subsea facilities. But we do the same onshore. We're working on shale gas. Shale gas is a hot topic nowadays in the south of Texas, or in the US in general, but particularly in the south of Texas. And in our group, we're particularly interested on the interactions between what are the environmental impacts, what are the societal impacts, what are the economic impacts, everything that is happening above the ground level, but also with everything that is happening below the ground level. So we're interested in what is the capacity of the reservoir, what is the potential of the reservoir to produce, what is the technology that we require to produce faster. So if you put that into the risk framework of geo-risk framework, we're training professionals to come up with answers to say, no, this is going to generate damage to the community because there's going to be air pollution, because there's going to be noise pollution, because there's going to be poverty. So there's no single energy project that environmentalists are not going to be interested in saying something about potential risks of having something going terribly wrong. So in our group, we look at integrating processes, integrating the geo processes with societal, economical, environmental processes. And I'm using the word processes because these are not stationary. These are things that are changing. So something that we are doing lately in our group is geo-risk mapping. We would like to have an online platform where any person could go and check where your property is and what is the process or the geological processes that are available and what are the future impacts in terms of species that are going to be running out or vegetation that is not going to be there in 5-10 years, so that we can make the proper decisions now to improve that. So this is basically anticipating on what could happen in the future, but what we know now on what is below the ground level, but also about the processes that are happening above the ground level.
So let me ask you real quick, just two more questions.
Sure.
What attracted you, what drew you to civil engineering instead of another kind of engineering?
My father is a civil engineer. But my father came from a very, I would say, poor family, and there was no road communicating. I mean, paved road communicating the place where he lived. And he used to tell me this story that one day he saw people, making measurements, and he asked, "What are you guys doing?" I said, "Oh, we're civil engineers." And so it was apparently the time where he said, I want to become a civil engineer. But it happened that then he became a civil engineer, and he traveled around many places, building dams, railroads, power plants, and it happened that I was there, traveling with him, looking at all what he was doing. So by the time that I had to make a decision about what I wanted to do, after many years saying I would like to do something else, I say, no, I think I'm going to be a civil engineer. And I don't regret it at all. So I think he made the right decision, and unfortunately, I guess it passed to me, and I don't regret it. That's the reason why I think I became a civil engineer.
And one last question: what do you think your students enjoy the most about your classes?
I would say I worked before becoming a professor. I had industry experience before joining a faculty team. So I bring a lot of that into my class. And I like that very much, because it's not the same just talking about theory of solving problems as compared when you say, you know, I had this problem and I didn't know how to solve it at the time, and I want you to help me in figuring out if there are better ways to solve this problem. So I think that is a challenge that I had at some point in my professional life, and I like setting that challenge for them. I think the same applies with research. With research, I ask them, find if there is someone else that is already that already has solved this problem. And whenever they figure out that there's no previous solution to a problem, it's like having that feeling of riding a bike for the first time or skiing for the first time. It's that sense of, oh, I'm the only one that owns this and that has the potential to come up with a solution. That is what I call research. And when you see the face of one of your students being challenged to solve a problem because we know that we can improve a solution, or whenever we're doing research and the student knows I'm the only one that is working on this and that can eventually solve this problem, that is just awesome. I think that that's something that I enjoy very much as part of my job duties at this, looking at the faces of students when they're challenged in that way.
Done. That was great.